Hello and Assalamualaikum. My name is Muhammad Najmi bin Nurizan. In this video, I will be presenting my final year project entitled Vibration Analysis on Motorcycle Handlebar. As you can see on the screen right now is my poster that will be used to present my whole final year project. We will move on to the first topic, which is abstract. Motorcyclists are road users that highly exposed to hand arm vibration that may contribute to body discomfort and fatigue that eventually will lead to road accident and health injuries. The two main objectives of this study is, the first one is to study the mechanical vibration of the motorcycle handlebar, and the next one is to understand the behavior of the motorcycle handlebar at different engine speed. This research will be conducted with an experimental setup on hand-arm vibration, measurement exposed to the motorcyclist using MPU 6050 sensor, which is accelerometer and gyrometer sensor, mounted on the right side handlebar of the motorcycle. The experiment was conducted on 3 different engine speed, which is 2000, 4000 and 6000 RPM for 10 seconds each. Result from this study shows that different engine speed is affecting the vibration exposed to the motorcyclist. Move on to the next topic, which is the introduction. Vibration is transmitted from the motorcycle to the following 3 parts. The first one is from the handlebar to the hand, arms and the body. The next one is from the saddle to the buttocks, the waist and the body. And the last one is from the footrest to the feet, the legs and the body. The vibration of the handlebar is caused by the engine vibration, the roughness of the road, and the vibration of the frame and the chassis. But in this study, the engine vibration will be the main concern of this study. This experiment is performed by using a model of complete motorcycle involving motorcycle body and handlebar motion. Furthermore, this experiment is tested at different engine speed, which, as mentioned before, which is 2000, 4000 and 6000 RPM for 10 seconds each, and the vibration of the motorcycle handlebar will be analyzed. Move on to the next topic, which is literature review. The standard used to quantify human vibration is ISO 2631 and ISO 5349. In regard to both ISO, vibration can be expressed in metric unit meter per second squared or units of gravitational constant G, where 1 G is equal to 9.81 meter per second squared. The coordinate system used to measure hand-arm vibration is shown in figure. As you can see in the figure, there is X, Y and Z axis acted on the motorcycle handlebar. So move on to the next topic, which is the methodology of the study. The first thing first is to get the literature review. In order to conduct the study, I have to get some information, and then parameter study to collect the data, and then installing the sensor. After all the information have been gathered, I'll installing the sensor to the motorcycle. I will be installing the sensor to the motorcycle handlebar. The next step is to set up the test vehicle. The next step is to run the experiment at 2000, 4000 and 6000 RPM of the engine for 10 seconds each. If all the experiments succeeded, conclusion and discussion will be made. And if one of the experiment is not succeeded, I will repeat the previous step, which is to set up the test vehicle. So move on to the next topic, which is result and discussion. As you can see in the screen right now, there will be 3 figures, whereby the first figure is the data for 2000 RPM experiment. The second figure is the data for 4000 RPM experiment. And the third figure is the data for 6000 RPM experiment. For 2000 RPM experiment, the highest acceleration on X, Y and Z axis is 3, 4 and 7 G respectively. This shows that on 2000 RPM of the engine, the handlebar tends to accelerate more along vertical direction, which is on Z axis, compared to other axis. The graph also shows that there is a minimal vibration on the motorcycle handlebar when the engine speed is running at 2000 RPM. So move on to the next figure, which is the data for 4000 RPM experiment. From the graph for 4000 RPM experiment, we can see that the values of acceleration for each axis is higher compared to 2000 RPM experiment. For 4000 RPM experiment, the highest value for X, Y, and Z axis is 10, 18, and 24G respectively. The increase of value for 4000 RPM experiment is because the engine is rotating at 4000 rotation per minute, which means for 1 second the engine will rotating at approximately 66.67 rotation, thus creating a higher value of acceleration for each axis. The major value of acceleration is once again at Z-axis with the value of 24G. Move on to the next data, which is 6000 RPM experiment. For 6000 RPM experiment, from the graph, all the acceleration value for each axis are much more higher compared to 2000 and 4000 RPM experiment. Therefore, we can conclude that as the engine RPM increase, the value of acceleration on each axis also increase. The highest acceleration value for this experiment is once again on Z-axis with the value of 26G. The highest acceleration value for X and Y axis is 15 and 19G respectively. The increasing value of acceleration at this experiment mainly because the engine is rotating 6000 rotation per minute. Each rotation will contribute to the vibration on the motorcycle handlebar. Acceleration value on each axis increases as the engine speed increases. The variation of hand arm vibration value is due to the inertia unbalance produced by the combustion process in the engine compartment. Move on to the next topic, which is the conclusion. The aim of studying the vibration of the motorcycle handlebar was achieved. From the result, we can conclude that as the engine speed increases, the acceleration, which is in G, value for each of the motorcycle handlebar also increases. That's all from me. Thank you very much for your attention.